Okay, I was asking how homework went because, so yesterday was area under a curve. Today is area between two curves. Okay, which in a technicality, we were doing area between two curves, except one of our curves was always the x-axis. Okay, so the difference is today that one of our two curves will not be the x-axis. You will have two unique curves. Okay, so if you think about it, we did that yesterday. We were doing the area under the curve, so we had to do just the area of the integral, right? If it was underneath the curve, we had to subtract it. Well, okay, you look at this here. Area between two curves. If f of x is my top curve and g of x is my bottom curve, notice it's the integral from a to b, so whatever your boundaries are, of f of x minus g of x. Notice f of x is my upper curve, g of x is my lower curve. Over here, if you're trying to find the area, if a is this intersection point, is b is this intersection point. F of x at this point is my upper curve, minus g of x is my lower curve. So it's always the upper minus lower is what I like to say. Okay, because needless to say, they're not going to be defined as f of x and g of x every time for you. It's the upper curve minus the lower curve. And we were doing that yesterday. Our upper curve was always, when it was positive, was just the basic curve. Our lower curve was the x-axis, which the x-axis is y equals 0. So we could do the upper curve minus 0 as your lower curve. Or if it was a negative area, it would be the idea of doing 0 minus the lower curve. So same idea. It's just we have two curves to work with. So let's look at example 1. Find the area of the region between the graphs of f of x equals x squared plus 2 and g of x equals negative x on the interval 0 to 1. Sometimes they'll give us an interval, sometimes they won't. Depends on the situation. Now, this one we can talk about the graph without having to use our calculators. Some of them will have to use calculators. Just kind of depends. So can you sketch this graph? F of x is x squared plus 2. How do we graph x squared plus 2? Yeah, it's a parabola. Shifted up 2. So there is my f of x. G of x is negative x. So what does negative x look like? Yeah. It's the line that goes through 0, 0, 1, 1, 2, 2, except it's negative. So it's the backwards line. It has that negative slope going through negative 1, 1, negative 2, 2, or 1, negative 1, 2, negative 2. And so I'm just going to, kind of, I don't know. Does that work for you? I didn't draw all the points there, but I feel like we're okay. And then it specifically says the interval from 0 to 1. And anytime they give you those intervals or boundaries, okay, at the stage of the game we're in, always remember these equations are in terms of x, so these are x values. Okay? Yes?
Do you ever have it where f of x, so there I said f of x is the upper and g of x was the lower, and then it's always upper minus lower. So what if f of x is lower and g of x is upper? Should we flip it or that one?
Always go with the idea of upper minus lower. Don't get hung up on,
f of x and g of x.
yeah, because they could give you, say, g and h. They won't always be defined as f and g. Okay, this one, coincidental. Maybe not coincidental, I don't know, but they are. F and G. Okay? But don't always count on that. And don't always count that if it is F and G, that it's going to be F minus G. Always think in terms of upper minus lower. Yeah. But in both pictures, F was the top curve. So. Okay, so the 0 to 1 are my X values. So do you see where we're finding the area? It's the area between the graphs, so between my parabola and my diagonal line on the interval 0 to 1. So that means from where X equals 0 to X equals 1. So do you see what we're doing here? If I draw a dotted line here at 1, how about my blue shaded area there? Is that what you were envisioning? Maybe? Okay. And in this case, the graphs aren't intersecting. So they had to give me an integral. Sometimes it'll be based on just the natural intersection points. They had to give me an integral here. So it's the integral from, what are the X boundaries they gave me? 0 to 1. And we can think, I would think upper minus lower, I guess is what I would say. What is my upper curve? Okay, in this particular case, it's X squared plus 2. So I'm going to write in, I don't want you to get hooked on, like Cassie was asking, f of X minus g of X. So I'm going to write in upper minus lower, because I don't want you to get hooked on the letters there. So the upper is the X squared plus 2. And then what's my lower? Negative X. So it's going to be minus negative X. And you could close your parentheses and then open another set if you want. But the key is that technically that whole thing has to be in one set of parentheses or bracket because that dx goes with everything. Now, what do you guys know about that minus negative x? It's really going to be plus x, isn't it? You know what to do here? You should. I don't know if we do or not, but...
Are we setting it into the 2? Putting the 1 and the 0?
Not yet.
Do the opposite of that.
So the integral or antiderivative?
Oh.
You can't plug the numbers in until you've taken the integral, which is the antiderivative, the opposite of the derivative. Just remember, derivatives, my powers go down, so antiderivatives, my powers go up. So what is the integral or antiderivative of x squared? X to the third over 3. I'll write it like that for a change. Plus, what is the integral of 2? 2x. It was minus negative, it's now plus. The integral of x. X squared over 2. And now, it's all evaluated from 0 to 1. So now what do I do? Okay, plug in the top, and then minus what you get when you plug in the bottom. So when I plug in 1, 1 cubed over 3, so 1/3, plus 2 times 1, 2, plus 1 squared over 2, 1/2. So it's going to be that quantity, minus, now we plug in 0, which is, are they all zeros? 0 plus 0 plus 0? So the key is 1/3 plus 2 plus 1/2. Okay. So 1/3 plus 2 3/6 plus 2/6 is 5/6. So 2 and 5/6, which goes improperly to 17/6. It's area again, so we're talking units squared.
So you do want all of our answers to be proper. What does it matter? I'm not on the AP test, it doesn't matter, but I can know.
Well, on the AP test, if you're thinking multiple choice, it'll be picking the right one. You won't see something like 2 and 5/6 on an official math test at this point. At least I don't think you would. I think it would go improper, that would be my guess.
Is today our last lesson before we start?
Yes.
So
Yes.
we'll be there again.
If I go around and make the copy real quick. I forgot to make the copies during my prep this morning.
We'll make it
So.
to the lesson.
So yeah, I can dash over and make the copies real quick so you have it. I just spaced it. So. Okay, ready to try example 2? Find the area of the region completely bounded by the graphs of f of x given there and g of x. And notice, did they give me an interval they want me to find this on? No. So it's going to be whatever natural boundaries are set once you look at the graph. Okay, 2 minus x squared. What can you visualize about 2 minus x squared?
Let's take a lot of
The graph?
just like the problem myself.
Similar to what I did last time.
Problems with the
Oh. Yeah. Okay, so 2 minus x squared. Negative x squared makes it an upside down parabola. Positive 2 takes it up 2. It'd be left to right if it was like within the x. So this parabola, instead of starting at 0, 0, is going to start at 0, 2. And if you think about that said parabola, and since I don't know my my boundaries yet, I'm going to have to be kind of thinking about what's going on here. If there's my vertex, we talked about parabola yesterday, didn't we? Or maybe I'm thinking pre-cal. If the vertex is at 0, 0, where's the next set of points? Over 1, up 1. So in this case, over 1, down 1. So it's going to be at 1, 1 and negative 1, 1. And then from there, it would have been over 2 and 4. So from the vertex over 2 down to 4, which would be down to negative 2. So I'm trying to get those dots in there because, again, we're going to have to find some intersection points. The more specific I can be, the better. And this is doable without a calculator. Okay? I know there'll be some today that won't be, but this is doable without a calculator. And then g of x equals x. What is that? Yeah, that's that y equals x line. So intercept of 0, slope of 1. So it goes through 0, 0. It goes through 1, 1, which I already have a dot. That's good. If I reverse it, it's going to go through negative 1, negative 1. And it's going to go through negative 2, negative 2, which is good. And yes, earlier I freehanded the line. I didn't care about the dots or the points because I didn't have to know exactly where everything was. This time, I care because I don't know my boundaries yet. Okay. So it was find the area of the region completely bounded by the graphs. So what are they asking me to do? Yeah, it's in between. Do you see the area we're looking at? Is this what you're thinking? That right there? Okay. In other words, the shape, whatever the piece that the two graphs form when they go together. So that's the area we're trying to look at. Now, what were these ordered pairs here? This ordered pair was 1, 1. This ordered pair down here was -2, -2. Now, specifically, is it my x's or my y's I use for my boundaries? X's. Because my equations are in terms of x. We're doing upper minus lower. So when we do this, and I know it's the same either way this case, right? But trying to prepare you for other cases. You're going to use the x values. Okay. And I guess the only other thing I can really label is that this equation was g of x. This equation happened to be f of x. Okay. So, the integral. From what to what? What are my boundaries? Okay, so from -2 on the left to 1 on the right. Your boundary should read left to right. So from -2 to 1. And then our brains are thinking upper minus lower. So in that section of the graph that I've shaded, which is my upper equation? The parabola. So I'm going to start with the 2 minus x squared, because that's that's the upper section. Minus, what's the bottom section? The line of x. And that is my upper minus lower. If there's any like terms you could clean up, I would go ahead and clean those up. I mean, there wasn't last time and there's not again, but just kind of an FYI. Okay. What do I have to do? Antiderivative. He's got it this time. Okay, so remember, antiderivative integral powers are going up. So 2 becomes 2x. Minus x squared becomes x cubed over 3. Minus x becomes x squared over 2. And then we are evaluating that from -2 to 1. Darn it, no 0 this time. Would have been nice, right? Okay, what do I start off doing? Putting the 1 in. So we're putting 1 in for everything. So 2 minus 1/3 minus 1/2. Minus, I'm going to do another set of parentheses. This time I'm putting in -2. So when I put in -2, -4, so it becomes -8/3, but it's minus -8/3, so it turns around and becomes plus 8/3. We won't even talk about the minus, it's back here though. And then -2, yep. Okay. 2 minus 1/3 minus 1/2. Well, 1/3 and 1/2 earlier was 5/6, right? So that's 2/6 and 3/6. So now it's 2 minus 5/6. 2 in terms of sixth is 12/6. 12/6 minus 5/6 is 7/6. Minus, let's see. I just need to put my whole numbers together first. -4 and -2 is -6. If I multiply that by 3 to make thirds, then that is -18/3. -18/3 plus 8/3 is -10/3. Or in other words, 7/6 minus -10/3, so that becomes plus positive. I need it all to really be sixth. So 10/3 is 26th. 7/6 plus 26th is 27/6. Technically would reduce. Okay. Not that you'd have to reduce, but you want to be able to identify the equivalents on a multiple choice question. They both divide, and become 9/2.
These aren't terrible.
They're not. They're really not. As calculus goes, this is one of the, there's certain things that I kind of despise, I'll be honest, and there's certain things that I really don't mind. And this falls into that, I really don't mind this one,
They always sound really hard.
Okay, moving along. Example 3. Find the area of the region between the graphs of f of x equals 2 minus x squared, g of x equals x on the interval 1 to 2. What do you know about this problem?
It's the same thing, only it gives us.
Okay. Same equations. Just this time, instead of it specifically saying completely bounded, it says interval 1 to 2. We don't have to regraph this if you don't want to.
Just the portion on the right side.
Yeah. Look up here. I'm changing color of pens so I can refer to a different color. Where is 1? It's on the interval 1 to 2. Remember, those are our x values, right? So here's 1 and here's 2. So can you see what I'm going to color in? It's from 1, which is this point right here, to 2, which that just means I'm kind of drawing a line. And so now we're going to do that section there. So my pink section is going down here. So now it's the integral. My interval is from 1 to 2. How do I fill in my integral?
Keep it the same way.
Are you sure it's the same way?
Oh, there's a different one on top.
What changed once we went through that point 1, 1?
The G of X is on top.
Which graph is on top now? Do you see what we're talking about? In the last one, the parabola was on top. At that intersection point of 1, 1, now x is on top. So when we do upper minus lower, it's going to be x minus the 2 minus x squared. That's the catch to watch for. You can't assume that the same one stayed on top. You would think, but you can't. So I'm going to do x minus, now be careful guys, it's minus the entire quantity 2 minus x squared. So I actually use brackets and parentheses here for my initial setup because I want you guys to be able to see x minus the 2 minus x squared. Now officially if I distribute that negative, it's really what? X minus 2 and then plus x squared. That's what I'm going to be integrating and working with. We've already integrated these pieces, haven't we? So x becomes x squared over 2 minus 2x plus x cubed over 3. Evaluated from 1 to 2. Okay, first we are plugging in 2. So 2 squared over 2, so that is 2 minus 4 plus 8/3. Minus, now it's the quantity. We're plugging in 1, so 1/2 minus 2 plus 1/3. Two minus 4 is negative 2. Now don't know, you do your fractions however you like to do them, but 2 minus 4 is negative 2. Negative 2 in terms of thirds is negative 6 thirds. Negative 6 thirds plus 8 thirds is 2 thirds. Or 6 thirds minus 12 thirds plus 8 thirds. Again, however. Over here, I feel like we already know. We kind of did this, didn't we? Yeah. 1/2 plus a third is going to be that 5/6. 5/6 minus 2. So 5/6 minus 12/6 is going to be negative 7/6. 2 thirds is 4/6. So it becomes 4/6 plus 7/6, which is 11/6. We have 1 or 2 on the back. We have 2. Okay. Did you guys get what you needed there? Example 4. Find the area region. Find the area of the region bounded by the graphs y equals x squared and y equals 2x squared minus 4. So again, you're either going to have to graph them precisely enough by hand that you know, or you're going to have to use the calculator. Okay? Well, regardless, I still want to, I'm going to draw a picture, so. And when we get to the next one, we have to use the calculator, so. Okay, what do we know about y equals x squared, or what's your calculator telling you? Parabola that goes through 0, 0, 1, 1, and, oh, I must have used the calculator on this one, based on the way I have it drawn. So I'm not drawing it the way I've drawn it in the past. I don't know, I did something different in the past, that's for sure. Okay, well, there's my initial parabola, right? Kind of lopsided, but you'll deal. 2x squared minus 4. Okay, so it's 2x squared minus 4, so it's a parabola still. It shifted down 4. There's my vertex. The 2 is going to make it a stretch, so it essentially makes it narrower. Okay? So at 0, 0, or excuse me, normally it'd be 0, 0. What the 2 is doing is, if it'd be 0, 0, 1, 1, 2, 4, the 2 is saying we're going to double what we would go up. So 0, 0, we're good. 1, 1, you'd normally go over 1, up 1. We'll double that going up 1. So you're going to go over 1 and up 2. So that really puts you at, what, 1, negative 2, negative 1, negative 2. And again, you could use the calculator to help you along here. And then 2. You go over 2, up 4 normally. But if we double that 4, we're going to go over 2 and up 8, which just so happens to overlap with the 2 4s we already had up there. Okay. Not the greatest, but the calculator can help you still, right? So, you know. And another thing is, if you're trying to figure out where those 2 pieces intersect, you could always set your equations equal to each other. Okay, you wouldn't necessarily have to have the picture drawn out. You could set the equations equal to each other. Okay. I should probably write down, what were these intersection points? 2, 4, and negative 2, 4, what's going to matter?
The 2.
The 2's, right? Because it's all based on x's. So when it says find the area of the region bounded by the graphs, my boundaries are from negative 2 to positive 2. So I'm doing the integral from negative 2 to positive 2 of what?
Negative x squared plus 4.
Don't go there yet, but yes, I agree. What's the beginning step for everyone to see? X squared minus the graph 2x squared minus 4. Now you could start integrating here, but it is so much in your better interest to combine like terms when possible, because I'll save you some integrating. So it's the integral from negative 2 to 2. What happens? We have x squared minus 2x squared. What's 1x squared minus 2x squared? Negative x squared. And then notice it's what? Minus negative 4, which makes it plus 4. So now I've gone from integrating 3 terms to 2 terms. The less the better, always. What's the integral of negative x squared? Negative x cubed over 3 plus integral of 4, 4x. Evaluated from negative 2 to 2. So if I plug in negative 2 to, what am I doing? Let's plug in positive 2. Don't know where my brain went. 2 to the third is 8, and so this is going to be negative 8 thirds plus 4 times 2 is 8. I've got that quantity. Minus, now I'm plugging in negative 2. Negative 2 to the third is negative 8. But then the negative of negative 8 makes this positive 8 thirds. And then plus 4 times negative 2, which is minus 8. I don't know. How do you guys want to do this? There's a couple of different ways you can do it. So you could. That's why I was debating what to, because this is 8 minus negative 8, right? So 8 plus 8, which is 16. Here you've got negative 8 thirds minus 8 thirds. Well, so this part is going to be the 16 thirds. It'd be negative 16 thirds. So there I'm at negative 16 thirds plus 16. Yeah. And so if I'm at negative 16 thirds plus 16, if I make 16 into thirds, it's going to be 64 thirds, I think. So negative 16 plus the 64. Somehow or another, you have to come up with 32 thirds. So probably it might have been better to say 8 is 24 thirds. Negative 8 thirds plus 24 thirds is 16 thirds minus a negative 16 thirds. Okay. B. Notice what it says. We can also utilize our graphing calculator. And as you start looking at those equations, what do you notice? I'm not graphing those in my head. X to the fifth minus 4x squared plus 1. Nope. Yep. 2x squared minus 4 I could graph by hand. But that first one, not happening. So, if you haven't already.
Don't say it, Jack.
Say what?
There's nothing to say yet. I think she just doesn't want you to say the answer. But there's no answer to say yet. Right now, We're graphing.
I just meant don't show the graph.
Oh, well, don't look up then. Because my graph is graphing.
Oh, that's perfect.
What, my screen went black?
Because I accidentally.
Well, there's nothing to see. Okay. So, now, can you guys tell what's happening here?
There are 3 intersects.
I'm zooming in.
Yeah, there's 3 intersects.
Dang it. I feel like my calculator's in slow mode. You know what? Never mind. Let's do a Z box. Should have done that to begin with. Okay, I'm going to Z box it.
Yeah, there's 3 intersects. So you have to make 2 separate ones. Make it twice. Or do it 2 separate times and add a little. And then
Okay, my picture does not do this justice at all. Sorry, you get what you get. My picture does not do it justice, but there's a reason we have it on the calculator, right?
Right.
The directions say, determine the area of the region bounded by the graphs. What do you see?
3 intersects.
Okay, so there's 3 intersection points. What are the areas I'm finding? Bounded by the graph. There's that big area bounded by the graph. And this little guy. So we are essentially setting up 2 problems. Now, before you go to setting them up, you're going to have to know all of these intersection points. Your calculator can do that for you, right? Remember, second calc, intersect. We only have 2 curves graphs, so the first curve is one of them, the second curve is the other one, and then you guess. Now, your guess is important. You have to move to which intersection point you're trying to find, because otherwise it won't necessarily give you what you want. So this one over here at the left is negative 0.86, I'll go 70, comma, negative 2.4967.
Ooh, I thought we were on the whole numbers.
It's calculus. No whole numbers here. Second calc, intersect. I'm going for another one. Wait, first curve, second curve. Now my guess. That's the important part that has to move. Because otherwise it's going to give you the same point 3 times. Okay, I'll let you round the whole numbers on this one. Is that not nice of me? 1, negative 2. They are whole numbers. And second calc, intersect. First curve, second curve, move your guess. And now 1.5905, comma, 1.0594. Okay. Calculator did the work for me. Integral. Let's do the big section first.
Negative 0.8670.
Okay. My boundaries are the x values. So negative 0.8670 to positive 1. Okay. Upper minus lower. Follow it. Which curve is that that's on top? That is the x to the 5th one. And so it's x to the 5th minus 4x squared plus 1 minus the quantity 2x squared minus 4. And then dx. That's area 1, so to speak. What do I have to do now?
Area 2.
I have an area 2, so it's going to be a big old plus. And we're going to do another integral. Thankful for our calculators, right? What do you know about this integral?
X squared.
Okay, so as you look at this is the little section, right? Which graph is on top if you follow it? The opposite one, the x squared. So this time, it's going to be the quantity of 2x squared minus 4 minus the quantity of x to the 5th minus 4x squared plus 1 dx. And what were my boundaries this time? My x values are 1 and 1.5905. And it's all about, can you hit all the right buttons on the calculator? I'm going to write down what I have written down in my notes for the answer. Don't look at the screen if you don't want to see it. And you remember how to do integrals on your calculator, right? I say math 9, Jack says alpha something.
Alpha of 2, 4.
There you go. Now, when you plug this in, I have 2 sets of parentheses, yes? You can do the 2 sets of parentheses. It might be easier so you don't have as many parentheses to just distribute your minus. Does that make sense? So I might do x to the 5th minus 4x squared, or I could even clean it up, but I was plus 1 and then minus 2x squared and then plus 4 dx, and then plus my next integral, which goes from 1.5905, and it is 2x squared minus 4 Okay, and there's my proof. If you plug it into the calculator right, you will get that answer. If you didn't get that answer, I don't know. Aubrey had 1 wrong sign yesterday. So, and I did drop my parentheses out of mine and just change my signs. You could do it differently, so.